Hey everyone, so in this lab we are going to be looking at the concentration of carbon dioxide in soda, specifically in Sprite. So the first thing we did if you were in class is we actually added some stuff to soda to see how that would affect how much carbon dioxide was in the soda. So obviously if there was less carbon dioxide, the soda tasted really flat. And if there was more carbon dioxide, the soda didn't taste flat. It still tasted fizzy. So what I want you to do before I tell you the results of that taste test is I want you to make some predictions. So I want you to predict if we add sugar or salt or oil to soda, will that make the CO2 escape more quickly so it becomes flat? Or will it make it escape more slowly so it stays fizzy? So just predict which effect each of these substances will have right here, and then come up with a reason for your prediction. Of course, your reason doesn't have to be right, but you do need to have some kind of reason for your prediction. So go ahead and do that now. Pause the video, make predictions in these 6 squares. You don't need to make a prediction for the control, which is just normal Sprite. Obviously, that would just taste as fizzy as normal. And then I'll tell you how fizzy they actually tasted. So pause the video now. Okay, so hopefully you're back. You've made your predictions. Now I'm going to tell you for sugar, when we added sugar to the soda, it made it pretty flat. So obviously the CO2 escaped. It's not very fizzy. The same thing happened with the salt. It also did not taste very fizzy. It was hard for me to tell which one was less fizzy, the sugar or the salt, but we'll look at that in a minute. Now the oil was still fizzy. Just tasted like normal soda with some oil in it. Okay, so now we are gonna do some more quantitative or take some quantitative data on what's going on here. And the first thing I want you to do is, hopefully you've watched the notes about molarity. If you haven't, you can watch them now. So watch those notes, calculate the molarity or the concentration of carbon dioxide that is in soda. So you've got 2.2 grams of CO2 dissolved in 355 milliliters of soda. That's how much is like a can is about 355 milliliters. So go ahead and calculate the molarity for that. Remember, to do that, you're going to need to set up a conversion factor chart like this, and you'll have your grams up here and your milliliters. Again, there's a video about how to calculate that if you need it. Okay, so what I have set up is, here, let me just bring you over here. So I've got beakers with Sprite in them. They all have 50 milliliters of Sprite, and the mass is fluctuating a little bit because it's really windy in here. But we have Sprite. This balance is measuring Sprite and sugar. Just the Sprite and the sugar. It's zeroed, so it's not measuring the cups or the beaker. This one is Sprite and salt. And this one is Sprite and oil. So what I want you to do right now is just record the initial mass for each beaker. So this control beaker that's not going to have any salt or sugar, its mass, we're going to say that's about 49.09. So in the control for its mass, you would write 49.09. Okay? And then you would do the same thing for this one is the sugar. So for the initial mass, and this is the Sprite plus the sugar, that's 55.19. So that's for the sugar, and you'd put that in that box next to the 50 milliliters. This is the Sprite and the salt, 56.94, I guess, right now. Or actually 95, 56.95. And then for the oil, we've got 55.90. Okay, so you should have those down on your paper. It's gonna look something like this. We said the oil was 55.90. This one is 56.95. And I don't remember what this one was. Whatever that one was, the sugar, write that down. Okay, so what I'm going to do now is I'm going to add the sugar to the Sprite, and we're going to see how much the mass decreases. And you can see what it looks like when I add sugar to the Sprite. Notice it fizzes quite a bit. And I'm going to add the salt. And that one fizzes even more. I have to add it really slowly. Okay, and then I'm going to add oil. Okay, we're going to let these sit for a minute, and hopefully you can kind of guess what's going to happen. As we let these sit, we're going to see that carbon dioxide is going to leave, or at least in some of them, carbon dioxide is going to leave, and you're going to see that the mass has gone down. So I'm going to show you the final mass of each solution, and you can go ahead and write that down in the final mass box. So maybe we need just a few more minutes, or maybe a few more seconds. In the end, what we're going to do is we're going to take the final mass minus the initial mass, and that will show how much CO2 was lost, if any, and then we'll go to that point. Okay, so we're just going to look now. My control is still at 49.09, so it didn't really lose any CO2. So we can say 0 grams of CO2 was lost. These are all grams. Let's look at the sugar. Now I forgot to write down what the sugar was before, but now it's kind of fluctuating. We'll say it's at 55.05. Okay, the salt, it looks like, is at, again, we're fluctuating a little bit, 56.89. Oh, actually, it's gone down to about 87, so 56.87. So obviously, like, you can see that we have lost some CO2 here. It looks like we lost about 0.08 grams. And then if we look over here at the oil, it's still at 55.90. So we didn't lose any CO2 in that beaker. Okay. So then what we can do is we can figure out how much CO2 is left in, not the can, but the beaker. So I calculated, I did this just on my own. There's going to be about 0.32 grams of CO2 in every 50 milliliters. So basically each of these beakers started out with about 0.32 grams of CO2. So since this one didn't lose any CO2, there's still 0.32 grams left in it. The sugar, you'll have to subtract those two numbers, and then this number you're going to subtract from 0.32. This one, it lost about 0.08, so 0.32 minus 0.08 would be 0.24 grams. So that's the amount of CO2 that's left in the salt beaker. And then the oil, it didn't lose any CO2, so there's still going to be about 0.32 grams left. Now all that's left to do for you is to set up these problems to solve for the molarity of CO2 in each of these solutions. So like our control solution has 0.32 grams of CO2 and 50 milliliters of solution. And then hopefully on the back, when you calculated the molarity, you figured out the molar mass of CO2. If you didn't do that, carbon is about 12 grams, oxygen is about 16, and there's 2 of them. So it ends up being about 44 grams in 1 mole. So you would need 44 grams of CO2 down here, 1 mole of CO2 up there, grams cross out, and then we know there's 1,000 milliliters in a liter. So then milliliters cross out, and then you can calculate that and get your molarity over here. And then you just do the same thing for each of these. They all are doing CO2, so they're all going to have the same molar mass. The only difference is they'll have different masses because you'll be using this number, and this number. And then you can figure out which one lost the most CO2. So which one has the lowest concentration of CO2, or which one had the greatest decrease. So yeah, let me know if you have any questions, but that's how that lab worked.